Hello, so this time I'd like to show you how to run JavaScript from Rust in WebAssembly and on the NEAR protocol blockchain. So this is from the Rust SDK for NEAR. And what I have here is I prepared a call to a smart contract that I've deployed, which contains this Rust code and also the JavaScript runtime in it. And what I will do here is just to run this small JavaScript. So we can just call it now and see what happens. And it's doing the function call. It takes a while, and here we see that it says hello from JavaScript, and we can also go into the console, to the browser I mean, and we can see the transaction actually on the blockchain itself. So let's go in there and just have a look, and we can see also here that we have the script as the argument, and it also logged this message hello from JavaScript. And there's another thing in this contract as well, because we can actually submit a script so that someone else can call it. So let's just submit that. Now it will not run it, but just store this script on the blockchain. So let's do that. And we can see now that it was compiled. It was 225 bytes of bytecode. This is the way that QuickJS works. It translated JavaScript to some bytecode, and we are storing that bytecode on the blockchain here. So now I can call this again. So I will just say that now I'd like to run the script that was stored from the account, my testnet account, which I used here for calling, for submitting. And let's just try running it. And we should see now that it says hello from JavaScript again. And we can also see that in the blockchain explorer here. So here you go. This time we just had the account ID as the argument, and we can see that it printed the output from the JavaScript code that was stored in the previous transaction. And I'll just go through the source very quickly. Here we can see that it's the Rust contract, so we can see these methods that we call. We had the run script, we had the submit script that will compile the JS, store it to this bytecode, store the bytecode into the account smart contract storage, and we also have this method for running the script for this given account, which will just load the bytecode from the storage and will run that. So that's it, and let's just move above here, and you can also see that I have this JavaScript library module, which is here, which actually contains the binding to QuickJS. And it somehow takes, well, I don't know why GitHub is so slow now, but you just bear with me and wait till this opens, this JSlib source. Otherwise, I will have to bring you into my VS Code. So. All right, so let's, I'm not sure why GitHub is not responding now, so let's just move in here and have a look at it from here. And we can see that, okay, we have the JSlib. Let's just look at it. We have the run.js, which is kind of evaluating the script. We have to give a file name, and we have the script pointer to the string. And so we can see also it references this external C library. So, and we have these methods in the C library. Actually, this comes from another project that I have, this compiled version of QuickJS, which is this, again, this, let's see how GitHub is now. This other project, QuickJS wasn't near. Well, doesn't respond right now, so I have that one here too. And let's have a look at that. We can see that here we have actually QuickJS. We have the library that I just showed you. So here we have the calling into QuickJS for compiling it. So you need this. You need kind of the. If we go back again to the QuickJS Rust, you see that I have some static libraries here, which are the compiled QuickJS from the other one. And also there's a few libraries from mscripten here, which is also needed. And there's also this mock of the WASI, because we actually don't want to compile to the WASI target. We want to compile to this WASM 32 unknown target. And we obtain that by just implementing some of the mscripten methods and the WASI methods. So, for example, this is essential for being able to write to the standard output or standard error. And building it is kind of straightforward. It's just like this. You just call the compiler just like you would do, and you deploy it. So the only thing missing right now that I will be working on next is to be able to do testing, because the near-js SDK is kind of limited at it compiles all the tests to your target platform, which is not what we want here. We would like to compile it to the WASM target. And that's especially because we are linking in C libraries, and we wouldn't want to provide kind of native versions of those C libraries, and then we wouldn't get the real test either. So that would be next thing to work on here. So thank you for watching this video. Sorry for the few network issues, but we got to show you the most important part anyway. So thanks. See you later.